Can you please give us an introduction, like you in your company, and you will tell you so far?
My name is Oleg Logvinov. I serve as CEO of a company called Iotecha. We work on smart charging of electric vehicles, where we combine digital and electric forces together. I also serve as a chairman of the working group working on high power line standards such as 1901.1, 1901.3, where we combine power line communication and wireless technologies, as well as 2413 family, which helps us to apply IoT architecture to the digitization of the power grid.
What do you see as the biggest pain point in the distribution sector?
If you look at the distribution grid, it was born over 100 years ago. It was born at the time when a single source of power was enough to basically waterfall power down to the loads. And the loads were quite predictable. Even up until very recent, if you look at what we typically encountered in a home, what was the largest load? An air conditioner. Very predictable, we could predict the load based on the temperature ahead of us a week ahead. Look at today. Today, we have electric vehicles, we have solar, highly unpredictable loads, and more importantly, highly unpredictable sources. So all of a sudden, from this cascading waterfall model that grid used to be for hundreds of years, we're transitioning to a new type of the grid, where energy actually can flow point to point in any direction. And danger of overload of transformer from the reverse power flow becomes even more important than danger of overload when the power cascading down to the loads. So the grid needs to transform itself to react to this new transformative green energy, mobile loads, and many other factors that now transform the grid into the next generation.
What specific impacts do these challenges have on power sector companies?
So what is the most important impact? The most important impact is that we no longer can accurately predict generation at the endpoints, as well as the load at the endpoints. The cloud came by and all of a sudden solar generation from the panel went down by 50%. An electric vehicle decided to charge because somebody came home for lunch and plugged it in. And all of a sudden you have 10 or 22 extra kilowatts that you need to source from the grid. But we have to remember, as I mentioned before, the grid was created many years ago, if not hundreds of years ago. And this cascading nature to predictable load allowed distribution companies to install transformers essentially relying on statistical multiplexing. In other words, not full capacity of all of the loads behind the transformer. Now we're in a different world. We may have loads that greatly exceed the capacity of the statistical multiplexing, and we have sources that also exceed in the reverse direction. So what do we do? How do we solve this problem? This is a challenge that is faced now with everybody in this industry.
How do ICT solutions facilitate the digital intelligent transformation of distribution infrastructure, particularly in addressing the grid challenges?
The answer is really ICT. ICT is the approach which essentially makes energy distribution intelligent. We cannot control every endpoint. We cannot control every single source connected to the grid. But what we can do, we can provide an orchestration of those energy actors behind the transformer, behind the meter, on distribution grid scale. But in order to do that, in order to enable such orchestration, we need a solution, an ICT solution. A great example of such solution would be Huawei's intelligent distribution system. That is a solution that allows us to monitor at high speed loads and sources connected to transformers. And that is very important because we need to understand the health of the grid. We need to understand its resilience. We need to understand what kind of capacity we have at every node of the grid. And then we can predict what we can do with it from the point of view of orchestration. But in order to do optimized orchestration, we need the edge and the cloud working in concert so we can provide good latency and intelligence of the decision making. Combined together, you have your whole solution. So instead of spending trillions of euros on rewiring the grid, we need to make it smarter. We need to make it as a living organism that can orchestrate itself with the help of ICT and deliver us an experience that actually can be enabled with all of this wealth of the renewable power that we can get from solar, from wind, and store in the batteries of electric cars that now are becoming multiple. It's a brilliant future.
Do you have any closing remarks or any thoughts overall about the industry that you would like to add?
We're living through a very interesting time. We're living through the time where actually we're democratizing the energy. If you think about every household can become a generator and the storage for the energy. Theoretically speaking, all of the energy needs of the house can be covered by the solar panels on the rooftop. And this energy can be stored in the batteries of electric vehicle parked in the garage of the same home. So technically speaking, at some point we can disconnect from the grid and become free of the wire. But actually working together as a cooperative of households with intelligence, storage capability, and generation capability, we can create a new grid that is peer-to-peer, not anymore cascading, not anymore waterfall. It is a democratized energy that also will help us to decarbonize our future.